So there's some general information up here that you might want to read about standard position, positive and negative rotations, coterminal angles, which is misspelled, and reference angles. I'm going to kind of hit the highlights of it. When we talk about an angle, we typically, at least as far as measuring it, we talk about an initial ray along the x-axis here, which would be like 0 degrees. And then we rotate it in this direction, in the same direction that our weirdly numbered quadrants, first quadrant, second quadrant, third quadrant, and fourth quadrants are. So something up here, that might be about 40 degrees going in this direction. Or if I go in the other direction, down here, this might be negative 35 degrees. So that's one of the basic ideas, is that we get the direction in the right way. And then there's something else called the reference angle here. And the idea is if I rotate all the way out to here, which is probably, let's see, that's 90 degrees, and that's maybe another 30. Maybe this is 120 degrees total. Positive 120 degrees to here. Well, that's what that is. But if that's 128 degrees here, the reference angle is the distance to the positive acute angle, so it's got to be positive, it's got to be acute, formed by the terminal ray and the x-axis, so in either direction. So my x-axis is here, so that right there is going to be, so I got 90 to here and an extra 30, that's going to be 60 left over. So my reference angle there is 60 degrees, if that's 120. If it was 121, then it would be 59. So those are some of the basic ideas. So let's look at a couple of the problems here, and we'll talk about coterminal angles when we get to them. But basically, coterminal angles are, and notice that the way it's spelled, there's no dash, just different ways to name the same angle, like did I wrap around more than once or backwards more than once. There's just multiple ways to say them. Typically, we like to give the number between 0 and 360, positive or negative, but we can go over 360 if we want, and that's where coterminal angles come in. So the first one here, for theta, which is what that symbol is, that's a theta, 145 degrees, draw a rotation diagram and identify the quadrant the terminal falls in. So the rotation diagram is more or less what this thing up here looks like. So it's a positive 145. If there's no sign, it's positive. I'm going to have a one side, a ray right here, which is one side of my angle. 90 is here, so 145 is somewhere out here. It's another 55 degrees past 90. So that would be my other thing, and so this is pretty messy here. But so from here to here is 145 degrees. And then it says what quadrant. So this is first, so this falls into the second quadrant. All right, let's skip ahead here. On exercise 3, it says give a coterminal angle. Okay, so the ID here is, well, 90 is me going from here to there in that direction, but I could wrap around, I could keep going, I could kind of go, you need to make that sound when you do it. And so that's plus another 360. So one option there is 360 plus 90, and that would be, what is that, 450? Except I didn't read the directions. Directions said a negative angle, okay? So the idea there is, so once again, I've got 90 here. I need it to be in the same spot, but what I can do is like, well, what if I go backwards like this? I still end up in the same place, but I'm going to specify that differently. So that's the 90, but then I went back 360. So I could either calculate it from here, which it's obvious to me that it's 270 there, or I can just say, well, 90 minus the 360 would be a negative 270. Negative 270 degrees is a coterminal angle. It names the same location that the angle has rotated to. So we want it to be like that right there. So it could be 450 plus 360 going around a second time, but based on the directions of a negative angle, I'm saying, well, I'm going to go backwards 360, which means to subtract 360. And I could do that multiple times. I could go backwards in 720, 1080, multiples of 270, and I can go forward that amount. So that's the idea of the coterminal angles. And then finally down here, we're looking for reference angles. And once again, reference angle is the idea of the horizon or the x-axis and just the acute angle there. So 160 would be almost 180. So we start over here. That's our initial ray. It goes over here to almost 180. Right there. Once again, my lines are terribly bad, not very straight. So that's 180 or 160. Okay. So my coterminal angle is actually this little piece right in here. So not my coterminal, my reference angle, which I underlined out here and you couldn't see, my reference angle is out here. So it's just 20 degrees. It's from the horizon here, or the x-axis, going up. And the way I got it mathematically, as I said, well, it's over here, it's going to be 180 minus the 160. Whereas if it's over here, if I gave you something like, for instance, gave you what's the reference angle of 20 degrees, well, that's just 20 degrees. I don't have to do anything. It's the acute angle between the x-axis and there, it's 20 degrees. But when it's more than this, or it ends up in one of these other quadrants, we have to see, well, what's that space between here and here, or if I had an angle here, between here and there, or if I had it all the way over here, it'd be the angle here. So once again, it's the acute angle. So we're looking at the x-axis and going up, it's going to be less than 90 degrees because it's acute. It's an acute little angle. All right, I think that might be all that I need to show you on this one. There's some other examples back here, so let me just do a couple of the examples. I'm not going to do the ones here. I'm going to make up some similar ones. But let's say I was looking for it says do a rotation diagram and state the quadrant. So same drill as before. And I'm going to use the number 400. I'm not going to use 560. I'm going to use 400. You use 560 when you do this. But so the basic idea here is the rotation diagram would look like this. My initial ray starts there. I rotate around. That's 360, but I'm going to keep going. I'm going to go another 40. It's going to end up about right there. So there's my terminal ray. And the quadrant that it falls in is 1, and it did not ask me, but I'm just going to go ahead and say the reference angle here. What would the reference angle be? So 360, and then I add another 40, and so that is the reference angle would be 40 degrees. Didn't ask it there, but it does in the next problem, and I'm just not going to do that now. I think that's enough for this one. I don't think there's anything else I want to show you. I think that's enough. Good luck.